The night shift begins, January 14th, 1942. Hut 11, Bletchley Park, Buckinghamshire, 03117 hours. The bomb shuddered to life, its drums spinning with mechanical fury that rattled the windows. Wren Joan Clark pressed her palms against the steel housing, feeling the vibration travel through her bones. The smell hit her first: hot oil, ozone, and the acrid tang of overworked electrical components. Around her, 5 other machines clattered in synchronized chaos, their copper contacts clicking through 17,576 rotor positions every few minutes. The heating had failed again. Frost crystals formed delicate patterns on the inside of the windows, and Clark's breath came out in visible puffs. She adjusted her wool gloves, fingers cut away for dexterity, and watched the drums rotate. Each drum represented an enigma rotor, 3 working in tandem, testing combinations at speeds no human team could match. Flight Lieutenant Gordon Welchman stood behind her, eyes fixed on the indicator panel where colored lights blinked in patterns only the initiated could read. He'd designed the diagonal board modification himself, the innovation that transformed Alan Turing's original concept into something truly formidable. His coat was pulled tight against the cold, collar turned up. "How many stops so far?" he asked, his voice barely audible over the mechanical din. 47 false positives in the last hour. Clark didn't look up from her logbook, pencil scratching coordinates and times with practiced precision. "The plugboard settings are giving us hell tonight." The plugboard, that damned plugboard. 10 pairs of letters swapped before the signal even reached the first rotor, multiplying the key space by astronomical factors. Welchman had done the mathematics 100 times. 3 rotors gave 17,576 positions. Add the plugboard with its 10 connections, and suddenly you were dealing with 150,738,224,937, 250 possible configurations, 150 trillion, more than every grain of sand on every beach in Britain. Behind them the door swung open, admitting a blast of January wind and Wing Commander Edward Travis. Snow dusted his shoulders. "Status?" he demanded, stamping his feet. "Running the Dolphin intercept from yesterday," Welchman replied. "The cribs are solid, weather reports from the Norwegian stations. Should have a break in the next 2 hours if the rotor order is what we think." Travis nodded grimly. Dolphin was the German Navy's home waters key, used by destroyers and coastal vessels operating in the North Sea and Baltic. Every day they didn't break, it meant convoys sailing blind, U-boats moving undetected, merchant ships going to the bottom of the Atlantic. The pressure sat on all of them like a physical weight. The bomb stopped, all drums frozen. The silence was shocking after the constant noise. Clark moved fast, checking the position indicators, copying down settings with rapid precision. "Stop number 48, rotor order 314, rings at 14:09:24, starting positions, QCW." She glanced at Welchman. "Running it through." "Do it," Travis ordered. Clark crossed to the Type X machine in the corner, set the rotors according to the bomb's output, and began typing the intercepted ciphertext. German letters emerged on the paper tape, slowly resolving into words. "Wetter Vorhersage Norwegen. Weather forecast Norway. then coordinates, wind speeds, visibility reports. "We're in," Clark said quietly. "This is it." Travis allowed himself a rare smile. "Good work. Get it to the watch." "I want every Dolphin message from the last 24 hours decrypted by Euro 600. He turned to leave, then paused. "And get someone to fix the bloody heating." The Polish Legacy, September 1938. Warsaw, Poland. The office of the Polish Cipher Bureau hummed with quiet intensity. Marian Rejewski sat at his desk, surrounded by pages of mathematical equations, rotor diagrams, and intercepted German messages. Outside, autumn rain hammered against the windows, but inside, Rejewski was warm, focused, chasing patterns through abstract algebra and permutation theory. The Enigma machine sat on the table before him, not a German military model, but a commercial version they'd acquired through intelligence channels. 3 rotors, each with 26 positions, wired internally in seemingly random patterns. When you pressed a key, electricity flowed through the rotors, bounced off a reflector, came back through the rotors in reverse, and lit a lamp showing the encrypted letter, simple in concept, mathematically devastating in practice. Rejewski had been working on this problem since 1932. 6 years of his life dedicated to understanding the internal wiring of those rotors without ever having access to German military documents. He'd used group theory, permutation analysis, and brilliant deductive reasoning, and he'd succeeded. By 1938, the Polish Cipher Bureau could read German Enigma traffic with remarkable consistency. But that was changing. Reports from Polish intelligence indicated the Germans were adding complexity, more rotors in the selection pool, increased plugboard connections. Rejewski ran the numbers again, his pencil scratching across paper. With 5 rotors to choose from instead of 3, the possible rotor orders jumped from 6 to 60. That was manageable. But the plugboard, the Germans called it the Steckerbrett, that was the real killer. Each plug connection swapped 2 letters before and after the rotor encryption. With 10 connections, you had to account for 150 trillion possible daily keys. Rejewski looked up at his colleagues. Jerzy Rojitki sat across from him, reviewing intercept logs. Henryk Zygalski worked at the drafting table, creating the perforated sheets that would help them filter rotor positions. They'd built bombs, the Polish machines, 6 of them, each designed to test rotor positions mechanically. But with the increased complexity, those machines were obsolete before they were finished. "We need to tell the British," Rejewski said, "and the French, before the war starts." Rojitki looked up sharply. "If we give them everything, we give away our intelligence advantage. If we don't," Rejewski replied quietly, "and Germany invades, all of this work dies here. The British have the resources, the manufacturing capacity. We have the knowledge. Together, maybe we have a chance." July 25th, 1939, the Pyrie Conference near Warsaw. Ruzhitsky, and Zygalski sat across from Commander Alistair Denniston and Dilly Knox of the British Government Code and Cipher School, along with Captain Gustave Bertrand of French intelligence. The atmosphere was formal, cautious. Nobody wanted to reveal too much too soon. Then Ruzhitsky opened his briefcase and pulled out a replica Enigma machine, complete with German military rotor wirings. Knox's eyes went wide. For 7 years, the British had been trying to reverse engineer those wirings from intercepted traffic. Now here it was, handed to them on a silver platter. "We've been reading German traffic since 1933, Ruzhitsky explained through a translator, but the Germans are adding complexity, more rotors, more plugboard connections. We estimate that within 6 months, our current methods will be insufficient." Denniston leaned forward. "What do you need?" "Industrial capacity, machine tools." "Electronics specialists." Ruzhitsky pulled out his mathematical analyses. "We've developed theoretical approaches, but we lack the resources to build machines at scale. You'll need devices that can test rotor positions simultaneously, exploiting logical contradictions in the cipher." Knox studied the equations, his expression shifting from confusion to understanding to excitement. "Good Lord," he muttered. "This is brilliant, absolutely brilliant." 6 weeks later, Germany invaded Poland. Ruzhitsky and his colleagues escaped through Romania, eventually making their way to France and then Britain. Their knowledge became the foundation for everything Bletchley Park would accomplish. Without the Polish breakthroughs, the war might have gone very differently. Turing's vision, March 1940, the British tabulating machine company factory in Letchworth. Harold Doc Keane stood in his workshop surrounded by half-assembled mechanical components and circuit diagrams. Before him, Alan Turing paced back and forth, hands gesturing as he explained his vision for a machine that didn't yet exist. "The Enigma's weakness is reciprocity," Turing was saying, his voice rapid, intense. "If A encrypts to T, then T encrypts to A. This creates logical chains we can exploit. Given a probable word, a crib, we can create a menu of relationships that must hold true across all rotor positions." Keane studied the diagrams Turing had drawn. "36 Enigma equivalents, working in parallel, testing contradictions at mechanical speed. The engineering challenges were staggering. Each drum needed 26 electrical contacts, precisely spaced, rotating in perfect synchronization. The relay systems had to detect logical impossibilities and keep searching, only stopping when a valid configuration appeared." "How fast does it need to be?" Keane asked. "Fast enough to test all rotor positions within a reasonable time frame. With good cribs, we should break a key in under 20 minutes. Turing stopped pacing, turned to face Keane directly. "Can you build it?" Keane was silent for a moment, mentally calculating materials, machining tolerances, electrical requirements. "It'll be expensive, and we'll need specialized components, bronze drums, precision bearings, custom relay banks." "The war effort has resources," Turing replied. "What we don't have is time." "Every day we can't read Enigma traffic means ships sinking, armies moving in the dark, surprise attacks we can't prevent." Keane nodded slowly. "I'll need 3 months, and a team of 20 skilled workers." "You have them." The first prototype, christened Victory, took shape through late winter. Keen's team worked 12-hour shifts, machining drums to tolerances of thousandths of an inch, soldering thousands of electrical connections, testing and retesting every component. The machine grew in his workshop like some vast mechanical brain, 8 feet tall, 7 feet wide, 1 ton of bronze and copper and determination. Gordon Welchman visited in February, bringing his diagonal board innovation. The problem with Turing's design, he explained to Keen, is that it only tests direct relationships, but the plug board creates cross-connections. My diagonal board adds reciprocal checking. If A connects to T through the plug board and T connects to something else, we need to account for those secondary relationships. Keen integrated the modification, adding another layer of complexity to an already complex machine. More drums, more relays, more electrical pathways. But the logic was sound, and Welchman's mathematics proved it would dramatically increase the bomb's effectiveness. March 18th, 1940. The test run. Turing, Welchman and Keen stood before Victory, watching as Keen threw the main power switch. The drums began to rotate, slowly at first, then building to full speed. The clicking of relays filled the workshop, a mechanical symphony of logical operations, executing faster than any human team could manage. The crib was a German weather report, intercepted from a Luftwaffe station that began every morning transmission with Wettervorhersage Biskaya, weather forecast Biscay. The menu was loaded, connections configured, assumptions programmed into the relay logic. 16 minutes passed. Then Victory stopped, all drums frozen at specific positions. Turing copied the settings with trembling hands. Rotor order IV2V, ring settings 06 to 1807, initial positions KBP. He walked to the Type X machine, configured the rotors, typed the ciphertext. German plaintext emerged. A weather report dated March 17th, transmitted at 600 hours from a station near Brest. Winds northwest 15 knots, cloud cover 8/10, visibility 12 kilometers. Keen exhaled slowly. She works. She works, Turing agreed. His voice was quiet, awed. Now we need to build 200 more. The Human Assembly Line, August 1941. The Wrens arrived at Bletchley Park in groups of 20, fresh from basic training, nervous and excited, and completely unprepared for what they were about to encounter. Wren Margaret Rock stood with her intake group in front of Hut 11, listening to the mechanical roar coming from inside. "That," said their instructor, Chief Wren Gilchrist, "is a bomb. You'll be operating them 16 hours a day, in 3 shifts. The work is classified, tedious, physically demanding, and absolutely vital to the war effort. You will not discuss it with anyone outside this facility, not your families, not your friends, not even other Wrens working in different sections." The door opened, and the noise intensified. They filed inside, blinking in the harsh electric light. 6 bombs lined the walls, each one shuddering and clicking, attended by Wrens in naval uniforms who moved between machines with practiced efficiency. Rock was assigned to Bomb Station 3, partnered with an experienced operator named Diana Scott. Scott had been at Bletchley for 8 months, her uniform showing signs of oil stains and electrical burns despite repeated washing. First rule, Scott said, shouting over the noise. Watch your fingers. These drums rotate fast, and the contacts are sharp. I've seen girls lose fingernails. She demonstrated loading a menu, a plugboard configuration based on suspected crib positions. This menu came from the watch. They've analyzed an intercept from the Mediterranean, think they've spotted the word general in the message. We test that assumption. Rock watched as Scott configured the machine, setting drums to starting positions, connecting wires according to the menu diagram. How long does each run take? Depends. Good cribs, 20 minutes. Bad cribs, 2 hours of false stops before we give up and try different assumptions. Scott threw the start switch. The bomb surged to life, drums spinning, relays clicking. Now we wait. The waiting was the hardest part. Standing in the cold, the bombs generated heat, but the huts were drafty, listening to the mechanical symphony, watching for the drums to stop. When a bomb stopped, you had seconds to record the position before it restarted its cycle. Miss it, and you'd wasted the entire run. Rock learned fast. Within 2 weeks, she could load menus without consulting diagrams, recognize false stops by sound alone, and maintain her machine through mechanical failures. The work became routine, almost meditative despite the noise and pressure, but some nights stayed with her forever. October 19th, 1941. Working the overnight shift with Scott. They'd been running cribs on an Enigma key called Dolphin, German Navy home waters traffic. 3 runs, all failures, false stops, bad cribs, wasted hours. Then, at 0423 hours, Bombay Station 3 stopped with a different quality to the silence. Scott checked the drums, copied settings, ran them through the Type X. German plain text emerged, coordinates in the North Sea, U-boat patrol assignments, fuel status reports. Get this to the watch, Scott said quietly, handing Rock the decrypt. Now. Rock ran through the frost-covered grounds to the main house, burst into the watch room where Hugh Alexander and Stuart Milner Barry were analyzing traffic. She handed over the decrypt, breathless. Alexander read it twice, his expression shifting. They're moving U-boats into position for convoy HX-156. This intercept is 8 hours old. If we're lucky, we can reroute the convoy before contact. He grabbed a telephone, started dialing the Admiralty. 3 days later, Rock learned that HX-156 had reached Liverpool with minimal losses. 1 merchant ship torpedoed, but 43 vessels saved. All because she and Scott had broken Dolphin that night, given the Admiralty enough warning to change the convoy route. That was when it became real. The mechanical tedium, the long shifts, the frozen fingers and aching backs, all of it bought lives. Every rotor position they tested, every contradiction they found, every key they broke meant ships that made it home, sailors who saw another day, families who didn't receive telegrams. The 4-rotor problem, February 1st, 1942. Bletchley Park descended into crisis mode. Every bomb in Hut 11 went silent simultaneously, their crews staring at machines that had suddenly become useless. The Germans had changed the game overnight. Commander Edward Travis stood in the main conference room, facing the assembled cryptanalysts, machine operators, and intelligence officers. His expression was grim. As of midnight last night, The German Navy introduced a four-rotor Enigma for all U-boat traffic. We're calling it Shark, and we're blind." The silence was absolute. Then erupted into chaos, voices overlapping, questions shouting over each other. Travis held up a hand for quiet. "The mathematics are brutal. 4 rotors instead of 3 means the key space multiplies by 26. Our current bombs can't handle it. They're configured for 3-rotor Enigma only. We need to rebuild them, add another drum set to each machine, reconfigure the relay logic." He paused, letting that sink in. "We estimate 9 months minimum." Alan Turing stood. "We can expedite, work with Keen's factory, prioritize the U-boat keys over everything else." "Convert the existing bombs one at a time while maintaining coverage of Army and Air Force traffic." "We don't have 9 months," interjected Harry Hinsley from Naval Intelligence. "Atlantic convoys are already suffering increased losses. The Admiralty is desperate. They're routing ships on guesswork and prayer. Every week we're blind costs dozens of merchant vessels." The room erupted again. Travis let them argue for 5 minutes, then cut them off. "Here's what we're doing. Keen's factory goes to triple shifts. We convert bombs on a rolling schedule. Turing and Welchman work the mathematical angles. See if there are shortcuts, ways to reduce the search space. Hut 8. Focus entirely on finding cribs in the Shark traffic. We need any advantage we can get." The months that followed were brutal. March passed with no breaks. April brought a single decrypt, but the key was 20 hours old by the time they cracked it, useless for operational purposes. May was worse. Atlantic convoys sailed into wolf packs they couldn't see coming. 74 ships went down in May alone. In Hut 8, the Naval Enigma section, tempers frayed. Hugh Alexander threw a typewriter across the room during one midnight shift. Sean Wiley stopped sleeping entirely, living on tea and determination. The Wrens in Hut 11 pushed their machines to breaking points, running 3-rotor cribs against 4-rotor traffic in desperate hopes of finding some mathematical miracle. Then, October 30th, 1942, HMS Petard, a British destroyer, depth-charged U-5559 in the Mediterranean. The U-boat surfaced, crew abandoning ship. Lieutenant Tony Fasson and able seaman Colin Grazier swam to the sinking submarine, climbed down into flooded compartments, and retrieved codebooks and rotor settings before U-559 went to the bottom. Both men drowned in the attempt. Their sacrifice gave Bletchley what it desperately needed: current rotor wirings for the 4-rotor system, daily key settings, and operational procedures. The codebooks reached Bletchley on November 24th. By December 13th, the first 4-rotor bombs were operational. December 13th, 1942, 2147 hours, Bomb Station 7 in Hut 11. Wren Sarah Norton loaded the menu for a Shark intercept picked up by Y Station Scarborough 18 hours earlier. The 4-rotor bomb, newly converted, still smelling of fresh paint and machine oil, shuddered to life. 43 minutes later, it stopped. Norton checked the settings, her hands shaking. Rotor order 86 for Beta. Rings at 03:17:21:01. Initial positions MQKR. She ran it through the Type X. German plain text emerged. U-boat positions in the North Atlantic. Weather reports, fuel status, course headings, everything. Norton didn't run to the watch. She walked, carrying the decrypt like it was made of glass, barely breathing. She found Hugh Alexander in the cafeteria, handed him the paper without a word. Alexander read it again, looked up at Norton with tears in his eyes. "We're back," he whispered. "We're back in the fight." The Daily Grind March, 1943. The war had settled into a grinding rhythm. Every day at midnight, German operators across Europe changed their Enigma settings, new rotor orders, new ring positions, new plug board configurations. Every day, Bletchley raced against the clock to break those keys before the intelligence went stale. The process began at the Y stations, listening posts scattered across Britain, picking up German radio traffic 24 hours a day. Bow Manor in Leicestershire, Chicksands in Bedfordshire, Scarborough on the Yorkshire coast. Wireless operators sat with headphones clamped over their ears, copying Morse code transmissions, noting frequencies and call signs and transmission patterns. The intercepts arrived at Bletchley by motorcycle courier, sorted by the registration room into different Enigma networks. Army keys went to Hut 6, Naval keys to Hut 8. Air Force keys split between both. Each hut had its own team of cryptanalysts searching for cribs, probable words that might appear in the traffic. In Hut 6, Stuart Milner Barry led the morning shift analysis. He spread intercepted messages across his desk, looking for patterns. Weather reports were gold. Germans had predictable habits, starting transmissions with Wetter Vorhersage or Wetter Null Sex. Standardized military formats helped too. Eins meant unit, Oberkommando meant high command. "This one," Milner Barry said, tapping a message from the Russian front. 6th Army traffic intercepted at 0430 hours. Look at the message length, exactly right for a situation report. And see this? He pointed to recurring letter groups. Stereotypical ending, probably Heil Hitler. His team built the menu, a diagram showing how the suspected plaintext connected through the Enigma rotors. If Heil encrypted to XMQZ, then certain logical relationships had to hold. The menu went to Hut 11, where Wrens loaded it into a bomb. Wren Patricia Bartley took the menu at 0920 hours, assigned to Bomb Station 12. She configured the machine according to specifications, connected wires following the diagram exactly. One wrong connection meant useless output, hours wasted, intelligence lost. The bomb ran for 37 minutes, stopped. Bartley recorded the position. Rotor order 2 for 5, rings 08 and 1319, starting positions TLA. She tested it on the Type X. Gibberish. False stop. The crib was wrong, or the rotor order was wrong, or the ring settings were wrong. She reset the bomb, tried different starting assumptions, another run, another false stop, third run, success. German plaintext emerged, a situation report from Stalingrad detailing ammunition shortages and casualty figures. This scene repeated hundreds of times daily across Bletchley's bomb network. By 1943, over 200 bombs operated in multiple locations: Bletchley itself, Stanmore, Eastcote, Wavendon. The machines ran around the clock, maintained by teams of engineers who kept them functioning despite constant breakdowns, overheating, and mechanical stress. The engineers had their own war to fight. Bomb drums wore out from constant rotation. Bearings failed under stress. Electrical contacts needed regular cleaning. Chief Engineer Peter Twin developed maintenance schedules that balanced operational needs with mechanical reality. Every bomb taken offline for repair meant potential intelligence lost. April 15th, 1943, 14:30 hours. Bomb Station 5 caught fire. An electrical short in the relay bank sent flames shooting up the wiring, thick black smoke filling Hut 11. REN operators evacuated while fire crews rushed in with extinguishers. The fire was contained within minutes, but the bomb was destroyed. Drums warped from heat, wiring melted, relay logic circuits burned beyond repair. The next day, a replacement bomb arrived from the factory. Installation crews worked through the night, had it operational by 0600 hours. The war didn't stop for fires or breakdowns or exhaustion. The Tonnage War, the Atlantic Ocean, 1943. The Battle of the Atlantic wasn't fought with guns and torpedoes alone. It was fought with mathematics, with rotor positions, with broken German signals that let Allied commanders see the wolf packs before they struck. In March 1943, German U-boats sank 108 merchant ships, 627,377 tons of shipping sent to the bottom. The statistics were staggering, unsustainable. Britain was an island nation dependent on imports. Food, fuel, weapons, everything arrived by sea. If the U-boats won the Tonnage War, Britain would starve regardless of military victories elsewhere. The Admiralty's Operational Intelligence Centre in London operated on decrypts from Bletchley. Commander Roger Wynne led the submarine tracking room, maintaining a massive plot of U-boat positions across the Atlantic. Every broken Enigma message added data points, U-boats reporting positions, fuel status, weather conditions, attack orders from BDU, Befehlshaber der U-Boote, commander of U-boats, Karl Dönitz. When Bletchley broke shark traffic, that intelligence flowed to Wynne within hours. He plotted U-boat positions, predicted patrol patterns, identified wolf pack formations, then worked with convoy routing officers to steer merchant ships around the danger zones. May 1943. The turning point. Bletchley was breaking shark regularly now, the 4-rotor bombs, handling the increased complexity. Allied convoys received routing changes based on ultra-intelligence, the code word for Enigma decrypts. Ships that would have sailed into wolf packs instead passed safely through empty ocean. The numbers told the story. German U-boats sank 34 merchant ships in May, a 68% reduction from March. But more significantly, Allied anti-submarine forces sank 41 U-boats. The hunters had become the hunted, and they didn't know why. Admiral Karl Dönitz sat in his command bunker in Berlin, studying loss reports with growing alarm. 41 boats gone in a single month. His wolfpack tactics, so successful in 1942, now seemed to be sending his crews into Allied ambushes. Either the British had developed extraordinary direction-finding capabilities, or, impossible thought, they were reading Enigma traffic. Dönitz ordered a security review. German cryptographic experts examined the Enigma system, found it mathematically sound. The 4-rotor naval version, they assured him, was unbreakable. They ran calculations proving that even testing one setting per minute would require millions of years to exhaust the key space. What they didn't understand was that Bletchley wasn't testing every setting. They were exploiting logical contradictions, using cribs to narrow the search space from trillions to thousands. The bombs didn't need to test every combination. They only needed to test the ones that made mathematical sense. June 1943. Convoy ONS-5 sailed from Britain to North America, 42 merchant ships escorted by destroyers and corvettes. German intelligence plotted the convoy's route, positioned a wolf pack of 30 U-boats across their predicted path. But Bletchley broke the shark key early, read the U-boat deployment orders 12 hours after transmission. The convoy routing changed overnight, steering ONS-5 200 miles north of the wolf pack. The U-boats waited in empty ocean while the convoy passed safely beyond their range. Donitz's forces sank 5 ships from ONS-5. The escort sank 6 U-boats. For the first time, U-boat losses exceeded merchant ship losses in a convoy battle. The mathematics of the tonnage war had reversed. The breaking point, late 1943. Bletchley Park operated at maximum capacity. Over 10,000 people working across dozens of huts, processing hundreds of thousands of intercepts monthly. The bomb network had expanded to over 200 machines, breaking Enigma keys faster than German operators could change them. But success brought its own problems. The sheer volume of decrypted material overwhelmed analysis sections. Messages arrived in German, needed translation, required intelligence assessment to determine priority and relevance. Traffic analysis specialists worked to identify which units sent which messages, building organizational charts of German military structure from radio patterns alone. In Hut 3, the Intelligence Translation and Analysis section, Squadron Leader Eric Jones led a team of translators working 12-hour shifts. German decrypts arrived on trolleys, stacked high with paper, each message requiring careful translation that preserved military terminology while making sense in English. "This one's interesting," said translator Peter Calvocoresi, holding up a decrypt from Italy. "Wehrmacht unit requesting ammunition resupply, but look at the quantities. They're listing ammunition types we didn't know they had in theatre." Jones studied the message. "Forward it to MI-14, Military Intelligence Analysis." "They'll want to update order of battle assessments." He grabbed another decrypt from the pile. "This is Luftwaffe traffic. Weather reconnaissance over the channel. Goes to fighter command immediately." The priority system was brutal and necessary. Top priority decrypts, those with immediate operational value, went out within 30 minutes of breaking. Second priority within 2 hours. Lower priority material might wait days for full analysis. Every message had to be sanitized, stripped of any indication it came from broken Enigma traffic. Recipients received intelligence disguised as coming from agents, direction finding, or reconnaissance flights. The deception was vital. If Germans suspected Enigma was compromised, they'd change systems overnight. All of Bletchley's work, all those broken rotors and tested combinations, would become worthless. So intelligence went out carefully, with cover stories, sometimes deliberately ignored to protect the source. November 1943, Coventry, England. Bletchley decrypted Luftwaffe orders for a major bombing raid targeting the city's industrial facilities. The decrypt arrived at 1400 hours. The raid was scheduled for 1900 hours that evening. The decision went to Churchill himself. Evacuate Coventry, and Germans would know their codes were broken. Let the raid proceed, and hundreds of civilians would die. Churchill chose to protect Ultra. Coventry burned. 568 people died. The moral calculus of intelligence work was savage. Every broken message forced impossible choices. Use the intelligence and risk exposure, or let operations proceed to protect the source. The people in Hut 3 who made those recommendations lived with the weight of their decisions. But the strategic value was undeniable. By late 1943, ultra-intelligence, almost entirely based on broken Enigma traffic, influenced every major Allied operation. North Africa, Sicily, Italy, the submarine war, strategic bombing campaigns. German forces fought brilliantly, but they fought blind, while Allied commanders saw their every move through decrypted signals. D-Day and beyond. June 5, 1944, 2200 hours. Bletchley Park operated under maximum security. Every bomber ran continuously, breaking Enigma keys for German forces in France. The intelligence mattered more now than ever before. 156,000 Allied troops were about to land on Normandy beaches, and their success depended partly on German confusion about the invasion location. For months, Allied deception operations had suggested the invasion would target Pas-de-Calais, not Normandy. Fake armies, dummy equipment, false radio traffic, all designed to convince German intelligence that Normandy was a feint. But to maintain the deception, Allied commanders needed to know what Germans believed. Enigma decrypts provided that intelligence. Messages from Wehrmacht units in France showed continuing belief that Pas-de-Calais was the primary target. Units remained positioned there rather than reinforcing Normandy. Field Marshal Erwin Rommel's requests for troop movements were denied based on false intelligence. The night before D-Day, Bletchley broke multiple Enigma keys simultaneously. Luftwaffe traffic showed reduced air reconnaissance over the channel due to weather. Wehrmacht signals indicated no major alerts along the Normandy coast. Naval messages revealed German surface vessels in harbour, not on patrol. That intelligence flowed to Supreme Headquarters Allied Expeditionary Force, where General Dwight Eisenhower made the final decision to proceed despite marginal weather. He knew from Ultra that German forces weren't expecting an attack. That knowledge made the difference between proceeding and potentially disastrous delay. June 6, 1944, 0630 hours. Allied forces landed on Normandy beaches. German response was slower than it might have been, partly because their commanders didn't believe Normandy was the main attack. Units stayed at Pas-de-Calais, waiting for an invasion that never came. Bletchley continued breaking Enigma throughout the Normandy campaign. Allied commanders read German strength reports, casualty assessments, resupply requests, tactical orders. The intelligence wasn't always actionable. Sometimes German forces fought desperately despite Allied knowledge of their positions. But it provided strategic awareness that conventional reconnaissance couldn't match. July 1944. The bombs in Hut 11 ran around the clock, processing unprecedented volumes of traffic. German forces in France were fragmenting, their communications increasing as units tried to coordinate withdrawals and counterattacks. More messages meant more cribs, more breaks, more intelligence flowing to field commanders. Wren operators worked exhausting shifts, maintained machines that were breaking down from constant operation. Margaret Rock, now a senior operator, supervised a team of 12 Wrens, managing 4 bombs simultaneously. They'd developed shortcuts, optimizations, ways to coax extra speed from machines designed for different operational tempo. "Station 7 is overheating," Rock called across the hut. "I need an engineer." Peter Twin appeared with his toolkit, began disassembling the relay bank while the bombie continued running. "How long has she been running hot?" 4 hours. We can't afford to take her offline. We've got 6 menus waiting." Twin worked while the machine operated, replacing components, cleaning contacts, adjusting drum alignments. The bombs had become like living things to the crews that maintained them, temperamental, requiring constant attention, but capable of extraordinary performance when properly cared for. August 1944. Paris fell to Allied forces. The Enigma traffic from France began declining as German units retreated into Germany itself. But new challenges emerged: increased encryption complexity, new rotor combinations, changing operational procedures. The Germans never suspected Enigma was broken, but they continually modified procedures to improve security against theoretical threats. The final months, January 1945. The war entered its final phase. German forces retreated on all fronts, but fought with desperate intensity. Enigma traffic reflected the chaos, fragmented communications, units out of contact with headquarters, improvised chains of command. Bletchley's bomb network processed this traffic with mechanical efficiency. The machines had improved through iteration: faster drums, better relay logic, more reliable electrical systems. Maintenance crews had learned to keep them running despite parts shortages and operational stress. In Hut 6, cryptanalysts noticed patterns in the chaos. German units were concentrating forces for the Ardennes offensive, though their communications suggested they lacked fuel and ammunition for sustained operations. The intelligence went to Allied commanders, who positioned reserves to contain the German breakthrough. The Battle of the Bulge demonstrated Ultra's value even in fluid combat situations. While German forces achieved surprise initially, Allied commanders received constant updates on German unit positions, fuel status, and operational intentions from broken Enigma traffic. The intelligence allowed rapid response, prevented strategic breakthrough, and contributed to German defeat. February 1945. Bletchley processed over 80,000 Enigma messages that month alone, an average of 2,157 daily. The bomb network operated at capacity, breaking keys sometimes within hours of their activation. German operators continued using Enigma, never suspecting their signals were transparent to Allied intelligence. The women who operated the bombs, over 1,000 Wrens by war's end, worked through the final months with growing awareness that victory was approaching. But they maintained operational security, never discussing their work, never revealing the existence of the machines they tended. March 1945. Soviet forces advanced from the east, Allied forces from the west. German communications fragmented further. Enigma traffic decreased as units lost contact, radio equipment was destroyed, and communications infrastructure collapsed. The bombs continued running, breaking what traffic remained. Every decrypt added to the intelligence picture helped commanders understand the final disposition of German forces, identified potential resistance centers, revealed attempts to move war materials and personnel. April 30th, 1945. Adolf Hitler committed suicide in his Berlin bunker. The Enigma network began dissolving as German units surrendered or were overrun. Bletchley processed final messages, surrender negotiations, last-ditch defense orders, desperate communications from units cut off from command. May 8, 1945, Victory in Europe Day. In Hut 11, the bombs fell silent for the first time in 5 years. Wren operators stood before their machines, exhausted, relieved, unable to fully process that the war was over. Joan Clark walked through the hut, touching each bomb as she passed. These machines had been her life for 5 years. 16-hour shifts, frozen fingers, mechanical breakdowns, endless menus and false stops and rare, triumphant breaks. They'd processed millions of rotor combinations, tested trillions of logical relationships, broken thousands of daily keys. The official statistics would remain classified for decades. Over 3,000 bombs built, processing hundreds of thousands of Enigma messages monthly at peak. Military historians would later estimate that ultra-intelligence shortened the war by at least 2 years, saved countless lives, prevented extended suffering. But the people who made it happen, the cryptanalysts, the Wrens, the engineers, the intelligence officers, couldn't speak of their work. They signed the Official Secrets Act, returned to civilian life, carried the weight of what they'd accomplished in silence. The secret victory. The bombs were dismantled after the war. Destroyed, actually, broken down into component parts. The drums melted, the relay systems stripped, the wiring recycled. The government couldn't allow the machines to survive. Their existence revealed too much about British cryptographic capabilities. Bletchley Park itself was nearly demolished. The huts fell into disrepair, used for storage or training exercises or nothing at all. The people who worked there scattered to normal lives, careers, families. They held reunion dinners sometimes, spoke in careful code about their war work, never revealing details. Alan Turing returned to pure mathematics and early computer development. He never received public recognition for his Enigma work during his lifetime. In 1952, he was prosecuted for homosexuality, subjected to chemical castration. He died in 1954, officially ruled suicide, though questions remained. His achievements at Bletchley stayed classified. Gordon Welchman emigrated to America, worked in defense electronics. His 1982 book, The Hut 6 Story, revealed too much classified information in the British government's view. He lost his security clearances, died in 1985, still persona non grata with British intelligence services. The Wrens who operated the Bombays went back to teaching, nursing, secretarial work. They raised families, built careers, lived full lives. Occasionally they'd recognize each other, a glance at a reunion, a shared understanding that couldn't be spoken. They'd been part of something extraordinary and carried that knowledge silently. Joan Clark, married briefly, returned to cryptographic work for GCHQ, Britain's post-war signals intelligence agency. She worked there until retirement, never discussing her wartime service in detail. When Bletchley's story finally became public in the 1970s, she gave occasional interviews but remained modest about her contributions. The truth emerged slowly. In 1974, Group Captain F.W. Winterbotham published The Ultra Secret, first revealing the existence of the Enigma breaks. The book was sensational. Historians had wondered for decades how Allied forces seemed to predict German movements with uncanny accuracy. Now they knew. More books followed, academic studies, documentary films. Gradually, the full story of Bletchley Park entered public consciousness. The scale of the operation was staggering. 10,000 people, processing millions of messages, breaking dozens of different cipher systems, providing intelligence that shaped the war's outcome. Modern historians estimate ultra-intelligence influenced 85% of major Allied decisions in the European theater. Every amphibious landing, every bombing raid, every convoy route change, all benefited from knowledge gained through broken Enigma traffic. The tonnage war statistics tell the story most clearly. In 1942, before four-rotor Shark was broken, U-boats sank over 1 to 600 merchant ships. In 1943, after regular Shark breaks, that number dropped by 65%. The submarine threat didn't disappear. German U-boats remained formidable weapons, but they fought blind while Allied forces read their every communication. The Battle of the Atlantic was won partly through depth charges and escort carriers, but also through mathematics, through Bombays testing rotor combinations, through Wrens loading menus, through cryptanalysts finding cribs in routine weather reports. Every convoy that reached port safely, every U-boat sunk before it attacked, every strategic decision made with knowledge of German capabilities, all flowed from those machines clicking through the night in Bletchley's huts. The numbers behind the victory final, accounting of Bletchley's Enigma operation, duration, September 1939 to May 1945, 69 months of continuous operations. Personnel, peak of 10,000 staff, including 8,000 women. Over 1,900 Wrens operated bombs throughout the war. Machines, 211 bombs built and deployed across multiple sites. Each bomb contained 108 drums, with 26 electrical contacts each, 2,808 connections per machine, 592 FAM488 connections across the network. Processing capacity. At peak, bombs tested rotor positions at a rate of approximately 20,000 settings per minute per machine. The network could process over 4 million rotor positions per minute across all machines operating simultaneously. Messages processed, estimated 3,000 to 4,000 German Enigma messages decrypted daily at peak operations, over 2.5 million messages total across the war. Rotor combinations. The three-rotor Enigma with plugboard had 158th, 962,555, 270th and 826th, 360,000 possible settings, approximately 159 quintillion combinations. The four-rotor naval version multiplied this by 26. Time to break. Average break time for a good crib was 15-30 minutes. Bad cribs could take hours or prove impossible. The fastest recorded break was 11 minutes for a Luftwaffe key in 1944. Intelligence value. Conservative estimates suggest Ultra shortened the war by 2 to 3 years. More aggressive estimates suggest 4 years. In terms of lives saved, the numbers run into millions, both military personnel and civilians. The cost of that intelligence: 2 men drowned retrieving Enigma materials from U-559. Hundreds of merchant seamen died in convoys that couldn't be rerouted before Shark was broken. The civilians of Coventry sacrificed to protect Ultra's existence. Countless others who died while intelligence officers made brutal decisions about when to act on decrypts and when to hold back to protect the source. The mathematics were elegant, the engineering brilliant, the operations executed with precision. But behind every broken rotor combination were human decisions, human sacrifices, human courage. The bombs were machines, but they were operated by people who understood what was at stake. Every false stop meant trying again. Every successful break meant intelligence that saved lives. Every shift worked through exhaustion and cold, and mechanical failures was a small victory in a war fought in shadows. Legacy Bletchley Park eventually became a museum. The site that nearly fell to developers now preserves the huts where history was made. Rebuilt bommies demonstrate the machine's operation for visitors. Exhibits explain the mathematics, the history, the human stories. The National Museum of Computing at Bletchley houses working replica bombs, built from original plans by volunteers who studied the machine's specifications. Visitors can watch the drums rotate, hear the relays click, see the mechanical ballet that broke the supposedly unbreakable cipher. Modern cryptography owes debts to Bletchley's work. The logical approaches developed there influenced early computer design. The organizational structures, separate teams for interception, analysis, intelligence assessment, became models for signals intelligence agencies worldwide. But perhaps the greatest legacy is the people, the mathematicians who saw patterns others missed, the engineers who built impossible machines, the wrens who operated equipment they barely understood, trusting that their tedious work mattered, the translators, the intelligence officers, the support staff who kept the operation running. They fought a secret war where victory couldn't be celebrated, where success meant no recognition, where decades of silence were the price of having been there. They accepted those terms because the alternative was losing to Nazi Germany. Every notch on those rotors represented millions of possible keys. Every combination tested was one step closer to reading German communications. Every broken message was intelligence that shaped operations, saved lives, brought victory closer. The bombs chewed through those combinations like a night shift snack, mechanical, relentless, unstoppable. Behind them stood thousands of people who understood that mathematics could win wars, that patience could overcome any cipher, that dedication and brilliance could break what seemed unbreakable. They were right. The rotors fell, the codes broke, the secret war was won.